Hi 6th graders, I hope you've been doing well. Today we are going to continue Unit 4, and this lesson is all about adding and subtracting mixed numbers. So our learning target for today is I can add and subtract using mixed numbers. Alright, so I want you to pause the video and fill out our white box, and then when you're finished we will get started working on our problems for today. Alright, so to add and subtract mixed numbers, the first thing that we want to do is we want to add or subtract the fractions, and then add or subtract the whole numbers, and lastly rename and simplify if necessary. Alright, so let's go ahead and get started. So starting with number 1, we need to find the sum or difference and then write in simplest form. Alright, so if you notice we have 4 and 5/9 plus 2 and 1/9. So the first thing that we want to do is we want to add our fractions. Okay, so I'm just going to write that down here. We're adding our fractions, and then when we're finished adding our fractions, then we need to add our whole numbers. So then we'll take 4 plus 2. Okay, so let's go ahead and get started. Our denominators are the same, so our denominator stays the same in our answer, and we take 5 plus 1, which gives us 6. Okay, so our fraction is 6/9. Now our whole number, we have a 4 and a 2 out in front. 4 plus 2 gives us 6. Alright, so our answer is 6 and 6/9. Can we simplify 6 over 9? Right, we could divide by 3. So when we divide both by 3, we have to remember to keep our 6 out in front. That 6 doesn't go away. Alright, 6 divided by 3 gives us 2. 9 divided by 3 gives us 3. So 6 and 2/3 is our answer. So go ahead and write that on the line. Perfect. I hope that one made sense. Now let's look at number 2. Alright, this time we're taking 5 and 1/4 plus 3 and 1/8. So the first thing we do is we add our fractions. But if you notice, our denominators aren't the same in this problem like they were for number 1. So we need to change it so that they do have the same denominators. Okay? So we have 4 and an 8. If we count by 4 and we count by 8, starting with 8, we get 8/16, and then 4, 8. The smallest number that they both share is 8, so we're going to make 8 our denominator. Okay, I'm going to erase all this work because we don't need it anymore. So we need to change 1/4 to have a denominator of 8. 4 times 2 gives us 8, so what we do to the bottom, we have to do to the top. 1 times 2 gives us 2. Alright, so we're really taking 2/8 plus 1/8. Alright, our denominators are now the same, so they'll stay the same in our answer. 2 plus 1 gives us 3. Is our answer 3/8? No, because we forgot about our 5 and our 3. So we need to add our whole numbers. 5 plus 3 gives us 8. So our answer is 8 and 3/8. These two are our answer. We just have to combine them. Awesome. And we don't need to simplify 3/8 because we can't divide both those numbers by the same thing. Moving on to number 3. We're still adding. This time we have 6 and 3/4 plus 1 and 2/3. Alright, so we need to add our fractions first, but if you notice, our denominators aren't the same. So we need to figure out what our common denominator is going to be. So if we count by 4s and we count by 3s, we get 4, 8, 12, 16. And counting by 3s, 3, 6, 9, 12. Which one do they both share already? Right, they both share this 12, so that's our common denominator. Okay, I'm going to erase all this work. Now we need to change both of our fractions to have a denominator of 12. So 3/4 is equal to something over 12. 4 times 3 gives us 12. What we do to the bottom, we also have to do to the top. 3 times 3 gives us 9. Alright, now we're going to do the same thing with 2/3. Denominator of 12, remember. 3 times 4 gives us 12. What we do to the bottom, we do to the top. 2 times 4 gives us 8. Alright, so we're really taking 9/12 plus 8/12. So let's rewrite that. Our denominators are the same, so they'll stay the same in our answer. Alright, and 9 plus 8 gives us 17. Perfect. Now we need to add our whole numbers. We're taking 6 plus 1. Well, that's easy. 6 plus 1 gives us 7. Alright, and then if we notice, our 17 over 12, we can simplify that. We can make that a mixed number. So to do that, how many 12s fit inside 17? Right, one whole one. 17 minus 12 gives us 5 left over, and our denominator stays a 12. So our answer isn't just 1 and 5/12. We need to add that with our 7. So take 7 plus 1, which gives us 8, and then our fraction. And we can't simplify 5 over 12, so 8 and 5 over 12 is our answer. Awesome. Now let's move on to some subtraction problems. Alright, so we have 8 and 7/10 minus 5 and 3/10. Alright, so if you notice, our denominators are exactly the same, so we can go ahead and subtract our fractions. 7 minus 3 gives us 4, and our denominator stays a 10. And then we need to subtract our whole numbers. We're taking 8 minus 5, which gives us 3. Alright, before we combine our fraction with our mixed number, or our whole number, can we simplify 4 over 10? Right, we could divide both of them by 2 because they're both even. 4 divided by 2 is 2. 10 divided by 2 is 5. So our answer is 3 and 2/5. Nice work. Alright, moving on to the next problem. We're taking 7 and 11 over 12 minus 4 and 5/6. Alright, so the first thing we do is we subtract our fractions, but our denominators aren't the same. So let's figure out what our common denominator is going to be. You might already know just by looking at them, but if not, then we count our multiples. So 12, 24, start with 6, 6, 12, 18. They already share 12, so 12 is our common denominator. Okay, I'm erasing all that. That's a review for us. We did that in Unit 1, and then we did it again in Unit 3. So if that is still not making sense, you have to reach out to me so that I can give you the help that you need, because we will be using this a lot this unit. Okay? Alright, so we need to change 5/6 to have a denominator of 12. 6 times 2 gives us 12. What we do to the bottom, we have to do to the top. 5 times 2 gives us 10. Alright, now this is the important part where some of us might get it wrong. This 5/6 and 10/12 matches with this one. So we're taking 11/12 minus our 10/12. Okay, you can't switch them around. It has to stay in order. Alright, our denominators are the same. 11 minus 10 gives you 1/12. Alright, our answer isn't 1/12 because now we need to subtract our whole numbers. We're taking 7 minus 4, which gives us 3. So our answer is 3 and 1/12. Perfect. I want you to try number 6 on your own and then come back and check your work. Alright, so we're taking 9 and 3/4 minus 6 and 2/5. So if you notice, we don't have common denominators, so we need common denominators. Counting by 4s and counting by 5s, we get 4, 8, 12, 16, 20. 5, 10, 15, 20. They both share 20, so that is going to be our common denominator. Alright, I'm erasing all this. So we need to change both of our fractions. So we have 3/4 with a denominator of 20, and then we need 2/5 with a denominator of 20. 4 times 5 gives us 20. What we do to the bottom, we have to do to the top. 3 times 5 gives us 15. Alright, our second one, 2/5. 5 times 4 gives us 20. What we do to the bottom, we have to do to the top. 2 times 4 gives us 8. Alright, so now we're really taking 15 over 20 minus 8 over 20. Alright, our denominators are the same, so it stays a 20. 15 minus 8 gives us 7 over 20. Can we simplify 7 over 20? Right, we can't. Alright, but we're not quite done because we forgot about our whole numbers. So we're taking 9 minus 6, which gives us 3. So our answer is 3 and 7 over 20. Perfect, I hope that made sense. Now let's move on to our second part of our lesson. Alright, now we're going to talk about what happens when we need to rename numbers to subtract. Okay, so go ahead and fill out the top of your vocab box. So what renaming fractions means is it's writing an equivalent number representing the same amount. Alright, so zoom into our picture. If you notice, we have 1, 2, 3, 4, 5 holes on both sides. Okay? What I want to show you is we can break up one of those holes into whatever our denominator is. Okay, so let's say our denominator is 8 for this fraction. We can break this box up into eighths. Is that 8? 1, 2, 3, 4, 5, 6, 7, 8. Yes. Okay, so what that means is, if you notice, it's the exact same amount. I didn't add any boxes. All I did was I split up one of my holes into eighths. Okay, so 5 and 0 eighths. Looking at this picture, I have 5 holes. I don't have any fractions. 5 and 0 eighths is the exact same thing as 4 holes and 8 over 8. Okay, so what that means is we can borrow from one of our holes and change it so that we have 4 and 8 over 8. 8 over 8 is really just 1. So 4 plus 1 gives us 5, and that's exactly what we had here. Okay? This will make more sense as we start going, but I just wanted to show you that. Alright, so we have 6 more problems. We're going to start with number 1. This time we are only subtracting. And then we need to write it in simplest form. Okay, so we are taking 5 minus 2 and 7 eighths. Well, if you notice, our 5 isn't a fraction, it's just a whole number. But we're subtracting by a fraction. So we want to make this 5 a fraction. Okay, so let's subtract 1 from the 5, which gives us 4. And our denominator is 8, so we have 8 over 8. This is the exact same thing as 5, just written in a different form. Okay, whoops. And now we're subtracting that from 2 and 7 eighths. So now this problem looks exactly like it did up above. Okay, we subtract our fractions first, and then we subtract our whole numbers. So we're taking 8 over 8 minus 7 over 8. Well, our denominators are the same. 8 minus 7 gives us 1. And then we need to take 4 minus 2, which gives us 2. So our answer is 2 and 1/8. Awesome, let's try another one. Moving on to number 2, this time we have 12 and 1/8 minus 9 and 1/4. So the first thing we need to do is we need to get common denominators because we need to subtract 1/8 minus 1/4. Okay? Our common denominator is going to be 8. We can get that if we count by 8s and count by 4s. Okay, I'll just show that for you. Now let's change our 1/4. So we're changing 1/4 to have a denominator of 8. 4 times 2 gives us 8. 1 times 2 gives us 2. Alright, so now let's rewrite this. We are taking 1/8 minus 2/8. Uh-oh. Can I do 1 minus 2? I can't. I'd get a negative number. So here's what we need to do. We are going to borrow one whole one from our 12. So that's going to change it to 11. Okay? But then we need to add 8 over 8 to our 1/8. Because we took one whole one and we changed it to our fraction, which is 8 over 8. So 1 plus 8 gives us 9, and our denominator stays in 8. Excuse me. Alright, so now this fraction is really going to go in this spot right now. So let's change that to a 9 over 8. Okay, our denominators are the same, so let's subtract. 9 minus 2 gives us 7. Alright, now let's subtract our whole numbers. We're taking 11 minus 9, which gives us 2. So our answer is 2 7/8. Moving on to number 3, we're taking 7 minus 2 1/4. Well, if you notice, 7 is a whole number. It doesn't have a fraction. So what we need to do is we need to make it a fraction. So remember, we take 1 from our 7, which changes it to a 6. And then our denominator is 4. So I would make a fraction where your denominator is 4. And it's 4 over 4. This is the exact same thing as 7. Alright, let's subtract our fractions. 4 over 4 over 1, or minus 1 over 4. Our denominators are the same. 4 minus 1 gives us 3. Okay, now we need to subtract our whole numbers. 6 minus 2 gives us 4. So 4 3/4. Excuse me, I have a tickle in my throat. Alright, moving on to number 4. This time we have 6 2/5 minus 3 3/5. Okay, our denominators are the same, so that's helpful. So we're taking 2/5 minus 3/5. Can we do 2 minus 3? No, we can't. So we need to take a whole from our from our 6, so that's going to change to a 5. Okay, so we have 2/5 right now, but we want to make another whole, which is 5 over 5. 2 plus 5 gives us 7, and our denominator stays a 5. Okay, so this 7/5 is really our 2/5, so let's go ahead and change that to a 7. Now we can subtract. 7 minus 3 gives us 4, and our denominator stays a 5. Now subtracting our whole numbers, 5 minus 3 gives us a 2. So that is our answer. I'm so sorry. Alright, moving on to number 5. This time I want to show you a different way to do this, okay? We could subtract to get our common denominators and borrow just like we've been doing in the past. Or we could convert both of these numbers to improper fractions and then get common denominators and then subtract. Okay, so let's go ahead and do that. To convert to an improper fraction, remember we take 10 times 8, which is 80, and then add 7. So 87 over 10. Minus 6 times 4 is 24. Plus 3 is 27 over 4. Alright, now we need common denominators. So between 10 and 4, let's count and see what our common denominator is going to be. 10, 20, 30, 4, 8, 12, 16, 20. Found it. 20 is our common denominator, okay? Alright, so we need to change 87 over 20, 87 over 10 to have a denominator of 20, and also 27 over 4 to have a denominator of 20. So 10 times 2 gives us 20, so we need to take 87 times 2. I don't know about you, but I don't have that fact memorized. So let's go over here and let's take 87 times 2. 7 times 2 is 14. 2 times 8 is 16, plus 1 is 17. So 174 over 20. Alright, now we have 4 times 5, which gives us 20. We need to take 27 times 5. So off to the side, let's multiply. 5 times 7 is 35. 5 times 2 is 10, plus 3 gives us 13, so 135. I'm going to erase my multiplying so I have a little bit more room. Alright, so now let's rewrite our problem. We're taking 174 over 20 minus 135 over 20. Okay, so let's go ahead and subtract those two numbers. I can't do 4 minus 5, so I need to borrow. 14 minus 5 gives me 9. 6 minus 3 gives me 3. So 39 is my numerator, and my denominator stays a 20. Alright, so we are all done subtracting. Now we just need to convert this back to a mixed number. Okay, so how many 20s fit inside 39? Right, if you count 20, 40, oh, that's too big, so only one. Okay, and then subtract 39 minus 20, which gives us 19 over 20, and that is our answer. Alright, so if that way did not make sense to you, if it didn't make sense converting it to an improper fraction first and then subtracting, and then converting it back to a mixed number, then I want you to stick with our way over here where we had to borrow. Okay, I'm going to do another example of converting to an improper fraction. So let's look at number 6. This is our last problem for today. We're taking 3 2/3 minus 2 4/5. So the first thing, let's convert it to a mixed, or an improper fraction. 3 times 3 is 9. 9 plus 2 is 11, and our denominator stays a 3. Minus 2 times 5 is 10, plus 4 gives us 14 over 5. Alright, but we need common denominators, so let's count by 3 and let's count by 5. 3, 6, 9, 12, 15, 5, 10, 15. 15 is our denominator. Alright, I'm going to erase this. So now we need to change both fractions to have a denominator of 15. Oops. Alright, 3 times 5 gives us 15. 11 times 5 gives us 55. 5 times 3 gives us 15. 14 times 3, I don't have that one memorized. 3 times 4 is 12. 3 times 1 is 3, plus 1 is 4, so 42. Alright, now we need to subtract them, so we're taking 55 over 15 minus 42 over 15. Well, our denominator stays a 15. 55 minus 42 is 13. And we cannot simplify 13 over 15, so that is just simply our answer. Alright, I hope that made sense. If it didn't, please reach out to me and send me a message on Schoology. Otherwise, I hope